Section 3.2 deals with direct variation. Here is the solve it problem that you have on page 176. Now you don't actually need to write this problem down, but I do want you to show the work in this section. This will lead you into what direct variation is. So here's what it kind of says. It is kind of blurry, so if you can't see this, that's okay, I will read it to you. The diagram shows how long it takes to hear thunder after you see lightning. What general rule can you use to model this situation? Explain. So what we have here is a bolt of lightning. Here we have one person. Here we have another. From the lightning bolt to this person, it takes 10 seconds. And here, the distance is 2 miles to the person. Here, the lightning bolt takes 15 seconds to reach this person, and the lightning bolt is 3 miles away. So what rule could you represent this situation? Well, if you know that 10 seconds is equal to 2 miles and 15 seconds is equal to 3 miles, you should realize that, well, wait a minute, 10 seconds is 2 miles. That means 1 mile, it's going to take about 5 seconds to reach 1 mile. Because 10 divided by 2 is 5, and 15 divided by 3 is 5. So 5 seconds would be at about a mile. So if you would actually be a mile from the thunder or the lightning, it would actually take 5 seconds. So if you heard thunder 20 seconds after you see lightning, how far are you away? So 20 seconds away. How many miles are you away? Well, if every mile is 5 seconds. If it's 20 seconds, 20 divided by 5 would give us 4 miles. So, here's what we do. Your equation would be this. Y equals X divided by 5. What that says is the number of miles, which is Y, depends on how many seconds. So what we do, we took X, which is the number of seconds, and divided by 5. Y is dependent on X. So now, turn your book to page 176 and look at the gray region. The time it takes to hear thunder varies directly with the distance from the lightning. Your essential understanding. If the ratio of two variables is constant, and in that case it was miles and seconds, and that's constant, then the variables have a special relationship known as direct variation. There is your vocab word. A direct variation is a relationship that can be represented by a function in the form y equals kx. It's also important to note that k cannot be 0, and here's why. If k was 0, this whole thing would just be y equals 0. The constant of variation for a direct variation, so the constant of variation for a direct variation, k, is the coefficient of x. So k is the number in front of x. That's k, that's your coefficient. By dividing each side of y equals kx by x, you can see that the ratio of the variables is constant. Y over x equals k. Now let me explain this. Y equals k times x. If I wanted to get the k by itself, you've done this. This is where you have to get the k by itself. So I want to get rid of the x. How do you get rid of a times x? You divide by x. So k equals y divided by x. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y equals kx, when k is not 0, it represents a direct variation. That sentence, or those two sentences, that is the main thing you need to understand with this. If you want to determine whether an equation represents a direct variation, solve it for y. Then you can write the equation in the form y equals kx, where k is not equal to 0. Now, here's the good news. This seems really hard, when in fact, it's not. It's just solving simple equations. So let's start some examples. Here are 2 examples that are not in your book. This is on the digital part that's online. You don't need to write these down. If you want to, somewhere in your book, you can. Here's what the question asks. Does the equation represent a direct variation? If so, find the constant of variation. Here's what it really means. Solve the equation for y. That's step 1. If you can, then you need to tell me the value of k. That's it, which is the number in front of x. So let's solve this equation for y. A, 7y equals 2x, divide by 7, divide by 7. That would give me y equals 2/7 x. Is that in the form y equals kx? Yes. So that works. The equation is in the form y equals kx. So the equation is a direct variation. The constant, which is the number in front of the x, the coefficient, k is 2/7, and that's your answer. B, let's solve it for y. Subtract 4x, subtract 4x. 3y equals 8 minus 4x. Divide everything by 3. I get y equals 8/3 minus 4/3 x. Now remember, this is all review. You've already done these type of equations. Literal equations, you've done these. So it says, can you write this in the form y equals kx? Is this in the form y equals kx? No, because we have this here. There's a constant. We don't have that. So therefore, this is no, not direct variation. So not direct variation. Whoops, not direct variation. We are now going to do the practice problems on page 176 to 177. Step 1, solve it for y. So in number 1, I divide everything by 2. That's going to give me y equals 5/2 x plus 1/2. That is not in the form of direct variation, y equals kx. So this one's nope, not direct variation. In number 2, negative 4 plus 4, they cancel. So that gives me 7x equals 3y. Solve for y. That would give me 7/3 x equals y. Is that in direct variation? Yes. So then your value of k, your constant of variation, is 7/3. The next part of your book is problem 2. This is the second thing they're asking you to do, and that's to write a direct variation equation. This problem is online. It's not in your book, but if you want to write it down, you may, but you do not have to. Suppose y varies directly with x. Now here's what that's saying. It's telling you that your equation has to be in the form y equals kx. X with x, and then y equals 35, x equals 5. What equation relates x and y? So what that means is they want you to write an equation. Then I want to know the value of y when x is 9. This is a very easy problem written with a very confusing question. All you do is this. I mean, this is honestly how easy it is. It's telling you to write an equation when y is equal to 35 and x is 5. All you do is plug in the two numbers. That's it. So I would get 35 equals k times 5. That's it. Now I have to solve for k, because here's the deal. Here's what I want. I want this equation right here. But the only thing I have to plug in is k. Well, I don't know k. So in order to find k, I have to plug in the x and y to solve for k. So back to this problem, I divide both sides by 5. That means k is equal to 7. So I take the k and I plug it in right here. So your equation is y equals 7x. That's the first problem. There's your equation. Y equals 7x. Now it asks, what's y when x is 9? So you take the 9 and you just plug the 9 in for x. And so the value of y would be 63. So this is your equation that relates x and y, and this is the value of y when x is 9. Let's try the got it problem. Suppose y varies directly with x and y, and then y equals 10, x equals negative 2. What direct variation equation relates x and y? So the first thing we do is use y equals kx. So what would I plug in for y? Good, it's 10. What do I plug in for x? Negative 2. So what letter do I need to solve for? I have to solve for k. Divide both sides by negative 2. K equals negative 5. So my equation would be y equals negative 5x. Now, it says what is the value of y when x is negative 15? So plug in negative 15 for x. So what is negative 5 times negative 15? It'd be 75. So my answer number 1 is this. My answer number 2 is this. I want you to try number 3 right now. See if you get it right. If you did number 3 right, you would get y equals 2 6/10 x. And if you plugged in 4 for x, y would be 31 2/10, or 31.2. So your answer is y equals 2.6x and y equals 31.2. Problem number 3, the third thing that your book is asking you now to do is now you're going to graph this thing. So here's the problem. You don't need to write this down, just watch. Weight on Mars y varies directly with the weight on Earth x. Keep in mind that you're understanding that Mars represents y, Earth represents x. The weights of the science instruments on board the Phoenix Mars lander on Earth is 130 pounds. And Mars, it's 50 pounds. What is an equation that relates weight in pounds on Earth x and weight on Mars y? Once again, we start with y equals kx, and this is how easy it is. You have all this gobbledygook, all of this stuff, that all they do is you need to find an x and y. It says right here Earth is x, so we find the x. Earth is 130 pounds. So 130 pounds will be plugged in for x. Y is Mars, and that's 50 pounds. So my equation is 50 equals k times 130. Divide both sides by 130. I get k equals approximately. You're going to have to do approximately. Now, when I want you guys to start getting used to this. Approximately, which I taught you a while back, is 2 wavy lines. It's approximately 38 hundredths, or 0.38. So my equation would be what? My equation would be y equals 0.38 x. There's your equation. So now we need to graph this. So my x here's what we need to think about. What am I doing here? What does my x and y represent? Well, x down here represents what the weight is going to be on Earth versus the weight on Mars. X and y vary directly. So what we need to realize is you can plug in 0, 1, 2, and 3 if you want. But wait a minute. I have 0.38. That means it's going to be so minuscule that you're barely going to have a line go anywhere. So I'm just going to count by 25s. You could count by 50. You could count by 100. It doesn't matter what you count by. So I'm just going to make a t-table here. 0. Well, 0, if I plug that in, is going to be 0. If I plug in 25, 25 times 0.38 is 9.5. If I plug in 50, 50 would give me 19. And 75 will give me 28.5. So I have to graph from 0 to 28.5. So I'm going to count by, let's say, tens. 10, 20, 30. So I graph this, 0, 0, 25, 9.5, 50, 19, 75, 28. This is going to be linear. Now notice, this should be a straight line. It's hard to do so on my iPad. But right here, there's no arrow because we don't have a negative. But it keeps going. And it's continuous because weight does fluctuate and change. And there's your answer. That's it. It's up to you to come up with a table of values. You could have counted by hundreds. You could have counted by 15s, 25s. It doesn't matter. The last thing you're going to do, the book wants you now to write an equation from a table. So first look at page 179 at the concept summary. Here's what this states. If you have an equation that's y equals kx, it will always pass through 0, 0. It'll always pass through the origin. And the slope will always be k. And this is going to be leading into more with slope later in this chapter. So you can rewrite a direct variation equation y equals kx as y divided by x equals k. When a set of data pairs x, y vary directly, y over x, or y divided by x, is the constant of variation. It is the same for every single data point. So, you're going to find this incredibly easy. This is probably the easiest thing out of everything you've done today. We're going to do problem 4. I'm going to do 2 tables. You do not need to write this down. Here are examples A and B. If you remember, all we have to know is this, y equals kx. Y equals kx. All I have to do is find k. Here's the deal. You can take this x value here, plug it in here, take the 6 value, plug it in here, or the 8 and the 12, or the 10 and the 15, and find k. But remember what we said. K is equal to y divided by x. Now watch what's going to happen. If I take 6y divided by 4, which is x, 6 divided by 4, it gives you 1.5. 12 divided by 8 is 1.5. 15 divided by 10 is 1.5. Automatically, you know k is 1.5. So my equation is y equals 1.5x. All you ever have to do to find k is take y divided by x. That's it. Let me rewrite this x here. So in the next problem, 3.2 divided by negative 2, sorry, that should be a negative 2. 3.2 divided by negative 2 gives you negative 1.6. 2.4 divided by 1 is 2.4. 1.6 divided by 4 is 0.4. Guess what? They're all different. Therefore, this does not work. And the y divided by x is not the same ratio for every ordered pair. So y does not vary directly with x. So this problem cannot be done. So if you do the got it problem, y equals, let's find k. It says y is 2.25. Take out a calculator if you don't have one. 2.25 divided by negative 3 is what? It's negative 0.75. What's negative 0.75 divided by 1? Negative 0.75. What's negative 3 divided by 4? Negative 0.75. So, my equation for the got it would be negative 0.75 x, and there's the got it.